Hey everyone, in this video we're going to go through identifying parallel or perpendicular lines from a graph perspective. Okay, so our first one is parallel lines. Parallel lines never meet, but they do have the same gradient, okay? So they have the same gradient, meaning they have the same slope, so they go in the same direction. Okay, so the way to check this is we need to look at the gradient of these two lines. Okay, so parallel lines have the same gradient. So let's find the gradient of this. So I'm going to pick this point here, and another point where they intersect is this point here. Okay, this one is going to be 0 on the x-axis and 2 on the y. This one here is going to be 2 on the x-axis and 5 as the y. Okay, so let's find the gradient of the blue line. So the gradient is equal to y2 minus y1 over x2 minus x1, or rise over run. Okay, I'm going to make this one y2, this one y1, x2, x1. Okay, and I'm going to go 5 minus 2 over 2 minus 0. That equals 3 over 2. And it goes in the negative direction. Okay, so it's going to be negative 3 over 2 because it's going down from left to right. Okay, so our first gradient is negative 3 over 2. Now, let's find the gradient of the purple line. Just going to move this over. Yep. One moment, please. Just not having much luck here. Okay, let's find the gradient of this line here. So I'm going to pick this point here, and I'm going to pick this point here. Okay, so this one at the top is going to be 0 on the x-axis, 5 at the top. And this one here is 2 on the x-axis and 2 on the y-axis. Okay, so let's find the gradient of this one. So our gradient of our purple line is equal to y2 minus y1 over x2 minus x1. Our x1, y1 is here. Our x2, y2 is here. So our y2 is 5 minus 2 over 0 minus 2, which equals negative 3 over 2 again. Okay, so our rise is 3, our run is 2. Our rise is 3, our run is 2. These have the same gradient. Okay, so therefore these two lines are parallel. Cool. Now let's have a look at perpendicular lines. Perpendicular lines, they intersect at right angles. Okay, so the product of the perpendicular lines' gradients equal negative 1. Or you could think of it as their gradients are negative reciprocals of each other. And what that means is, so we look at the gradients once again, okay, and we see if they are negative reciprocals, okay. What that means is 2, the negative reciprocal of 2 is flipped. So 2 over 1, let's do 2 over 1, is flipped and there's a negative in front of it. So the 1 goes at the top, the 2 goes at the bottom, and the negative comes out the front to create negative 1 over 2. Okay, and that's the same with any fraction or whole number, okay? With this one, we've got 3 over 4. If we flip that, put the 4 at the top, the 3 at the bottom, and put a negative in front of it, its negative reciprocal is negative 4 over 3. Okay, and these times together to make negative 1. Okay, because 4 divided by 4 is 1, 3 divided by 3 is 1, and minus 1 times 1 is negative 1. Okay, and that's how you prove that they are negative reciprocals of each other as well, other than just by sight. Okay. Cool. Let's prove that this graph here is perpendicular. Okay. So we look at the gradients. So I'm going to do the purple line first. Okay. I'm going to pick 2 points where they intersect on the grid nicely. So this one here is going to be 4 on the x-axis, 5 here. And this one is going to be 3 on the x-axis and 3 on the y-axis. Okay, I'm just going to do a quick rise over run by using the grid. So this rise is 2 over 1. This is 2 over 1. I'm going to use a smaller pen. So our gradient of our first one is 2 over 1, which is positive 2, okay, because it's going in the positive direction. It's going up from left to right. Now let's look at the blue one. Okay, I'm going to pick this point here and this point here. This goes up 1, but across 2, 1, 2. So, and it's a negative gradient, okay, because it's going down from left to right. So, M2 is negative 1 over 2. Negative 1 over 2 is the negative reciprocal of 2. Therefore, these lines are perpendicular. Okay, so it's up to you how comfortable you are with gradient. If you want to do it like I've done it with the perpendicular lines, or if you want to do it with the formula, okay, which was given here. Okay. Last but not least, we have intersecting lines. These are neither parallel nor are they perpendicular. Okay, so they don't satisfy the same gradients as a parallel line, which are the same, and they are not negative reciprocals of each other. Okay, so let's prove that this is neither parallel nor perpendicular. Okay, so I'm going to pick 2 points. Let's do this one and this one. It goes up 2, it rises 2, across 2. So this gradient is 2 over 2, which equals 1. Okay, now let's do the purple line. Our purple line goes through this point here and this point here. It goes up 2 and across 1. Oh, my bad, I'm going too fast. Our blue line is actually negative because it's going down from left to right. So this is a negative 1. Now our purple line's gradient is 2 rise over 1 run. And it's going in the positive direction, so it stays positive. So this gradient is 2. These two are not the same, and they are not negative reciprocals of each other. Therefore, these are neither parallel or perpendicular. Okay, so that's how you do those 3. If you have any questions, please include them in the private comments. Otherwise, good luck with the questions.